Our universe is a vast and enigmatic place, filled with more wonders than we can possibly imagine. As we gaze up at the night sky, we are greeted by the twinkling lights of distant stars, gathered together in swirling galaxies that stretch out to the very edge of our perception. Yet what we see with our eyes, those majestic spirals of light, only tell a fraction of the story. Hidden from our view, lurking in the shadows, lies a substance that holds the key to understanding the universe's deepest secrets: dark matter. Imagine a cosmic dance, a graceful waltz of stars and gas held together by an invisible force. That force, my friends, is gravity, the glue that binds the universe together. But here's the catch. When astronomers add up all the matter we can see, stars, planets, gas clouds, they find it's not nearly enough to create the gravity we observe. There's something else out there, something massive and unseen, holding it all together. That something is dark matter. It's a mysterious substance that doesn't interact with light, making it invisible to our telescopes. We can't see it, touch it, or smell it, yet we know it's there because of its gravitational pull on the visible universe. It's like trying to understand a play when you can only see half the actors on stage. The story doesn't quite make sense. Dark matter makes up a whopping 85% of the matter in the universe. It's the invisible scaffolding upon which galaxies are built, the silent conductor orchestrating the cosmic ballet. Unraveling its secrets is one of the biggest challenges facing modern science, a challenge that could rewrite our understanding of the universe and our place within it. To understand the origins of dark matter, we must journey back to the very beginning, to the birth of the universe itself, the Big Bang. In that infinitesimally small point, all of space and time were compressed into an unimaginable singularity. Then, in a cataclysmic explosion, the universe was born, expanding and cooling over billions of years to form the cosmos we see today. As the universe expanded and cooled, tiny particles began to clump together, forming the first atoms. These atoms, mostly hydrogen and helium, were the building blocks of stars and galaxies, the seeds from which the visible universe would eventually sprout. But something else was happening in those early moments, something invisible and mysterious. Dark matter too was being forged in the crucible of the Big Bang. The exact nature of this primordial creation remains a mystery, but we have a few clues. The leading theory is that dark matter is made up of weakly interacting massive particles, or WIMPs. These hypothetical particles would have been created in abundance during the Big Bang and, unlike normal matter, would not have interacted with light or other particles, leaving them free to clump together under the influence of gravity. Another possibility is that dark matter is made up of axions, another hypothetical particle with unique properties. Axions are thought to be much lighter than WIMPs, but they could have been produced in vast numbers during the Big Bang. Unlike WIMPs, which interact only weakly with each other, axions can interact with electromagnetic fields, potentially offering us a way to detect them. Detecting something that doesn't interact with light might seem like an impossible task, but scientists are a resourceful bunch. They've devised a number of ingenious experiments to try and catch dark matter in the act, hoping to glimpse these elusive particles as they pass through our planet. One approach is to look for the faint glow that some theories predict dark matter particles might emit when they collide and annihilate each other. Deep underground, shielded from the constant bombardment of cosmic rays, scientists have built sensitive detectors designed to pick up these faint signals. These experiments, like the Lux Zeppelin experiment in South Dakota, are like listening for a whisper in a hurricane, hoping to hear the faintest whisper of dark matter interactions amidst the background noise of the universe. Another approach is to try and create dark matter particles ourselves. At the Large Hadron Collider, the world's most powerful particle accelerator, scientists smash protons together at nearly the speed of light, creating a shower of exotic particles. The hope is that, amidst this subatomic debris, they might find evidence of dark matter particles being created and decaying. Finding such a signature would be a major breakthrough, providing definitive proof of dark matter's existence and offering valuable insights into its properties. While the search for individual dark matter particles continues, we can already see the profound influence of dark matter on the universe around us. In fact, you could say that dark matter is the invisible architect of the cosmic web, the vast network of galaxies, galaxy clusters, and filaments that make up the large-scale structure of the universe. Remember that dark matter doesn't interact with light, so it doesn't experience the same kind of pressure that normal matter does. This means that, in the early universe, dark matter was free to clump together under the influence of gravity, forming vast halos of dark matter that would eventually serve as the gravitational seeds for galaxy formation. As normal matter fell into these dark matter halos, it cooled and condensed, eventually forming the stars and galaxies we see today. Without dark matter, galaxies would likely never have formed, and the universe would be a very different place. By studying the distribution of galaxies in the universe, astronomers can map out the underlying distribution of dark matter, giving us a glimpse into the invisible scaffolding upon which the cosmos is built. The hunt for dark matter has led some physicists to propose even more exotic possibilities. One intriguing idea is that dark matter might not be made up of particles at all, but rather, it could be a manifestation of extra dimensions beyond our own. In these theories, our universe is just one of many brains or membranes floating in a higher dimensional space. Just as a shadow can appear on a wall, these theories suggest that dark matter could be the gravitational shadow of particles and forces existing in these hidden dimensions. These shadow particles would be invisible to us except through their gravitational pull, potentially explaining why dark matter interacts so weakly with normal matter. While these ideas are highly speculative, they highlight the incredible lengths to which physicists are going to try and unravel the mystery of dark matter. The quest to understand dark matter might seem like a daunting task, but it's important to remember that every great scientific discovery started with a question, a spark of curiosity about the world around us. And in the grand scheme of things, our understanding of the universe is still in its infancy. Each new experiment, each theoretical breakthrough, brings us one step closer to shedding light on this cosmic enigma. Whether we find that dark matter is made up of WIMPs, axions, or something even stranger, the discovery will have profound implications for our understanding of the universe and our place within it. The Dark Matter Enigma is a stark reminder that we've only just begun to scratch the surface of the universe's mysteries. It's a humbling thought, but also an incredibly exciting one. There's so much more out there to discover, so many secrets waiting to be unlocked. As we continue to explore the cosmos and push the boundaries of our knowledge, we can be sure that the coming decades will bring about even more astonishing discoveries that will reshape our understanding of the universe and our place within it. And who knows, perhaps one day, the Dark Matter Enigma will be just another chapter in the grand story of scientific discovery.